So today's objective is you should be able to draw and interpret the displacement time, velocity time and acceleration time graph. So in O levels, you have already studied the displacement or distance time and speed or velocity time graph, but you did not study the acceleration time. So you should be able to draw as well as interpret acceleration time graphs as well. So if we have a displacement time graph, so displacement on y-axis and time is on x-axis. So what the slope represent for a displacement time graph or distance time graph, the slope represent velocity or speed. And if we have a velocity time graph, so what slope represent? The slope represent acceleration. If we have a velocity or a speed time graph, the slope is representing the acceleration. And what about the area under the graph? The area under the graph will give us the distance traveled. So it is important to understand the concept of the slope, how we explain the slope of a graph. Slope means angle with x-axis, basically the angle which the graph line is making with an x-axis, that is refers to slope. So if we have any quantity on y-axis, another quantity on x-axis, and it is a straight line, horizontal line. So if it's a horizontal line, what we can say about slope of a horizontal line, because its angle is zero, it's not making an angle, any angle, so we'll say the slope is equals to 0. So horizontal line, always the slope is 0. But if there is a straight line which is passing through the origin and making a constant angle, so on y-axis we have any quantity, on x-axis another quantity, and we have a straight line. So if we have a straight line, angle is constant. So if angle is constant, what we say? We say the slope is constant, or slope or angle is not changing. And what about the value of the slope? Because the slope can be a positive slope or a negative slope. So how you can identify whether a slope is positive or negative, or the value of the slope will be positive or negative? So you have to check 2 points. Like when I take 2 points of the line and identify them on y-axis, the first point on y-axis, that's called y1, and the second point on y-axis, that's known as y2. So you can see the y2 is above y1. So whenever y2 is above y1 or y2 is more than y1, then the value of the slope will be positive. Like when we calculate the slope by using a formula, that slope or a gradient is equals to y2 minus y1 over x2 minus x1. So in this case, the slope, like it will be a constant number, a fixed number, and the value of that will be positive. But what about the negative example? If we have another graph like this, and we want to identify whether, as we see that because it is a straight line, whenever the line is straight, it means the angle is not changing, so we say slope is constant. But what about the value of the slope, whether it is positive or negative? So how we can work out? When we mark the 2 points, the first point we mark, that's on y-axis, that's called y1, and the second point which we mark on the line, that's y2. So you can see here y1 is above y2. So when y1 is above y2, it means the value of the slope will be negative. So The difference, if I say both are making the same angle, but the answer for this one will be plus 4 and this will be minus 4. This is just an example. Is it clear? First, the concept of the slope. Slope means the angle with x-axis, and a slope can be have a positive value or slope can have a negative value. So if I say another graph, so that is y and x, and we have a graph line in this manner. So what is happening to the slope? Is it increasing, decreasing, constant, or zero? Because these are the four things that a slope can have. Either a slope will increase, it will decrease, it will be constant, or it will be. So in this case, the slope is increasing. That's right. And what about the value of the slope, whether it is a positive or negative? So how we can work out when we mark the first point, that's called y1, and we mark the second point on the line, that's called y2. So you can see y2 is above y1, so slope is increasing and it will have a positive value. Like when you calculate the slope or gradient, you will get the positive answer. But it can be other way around. So we have two quantities, one is on x-axis, another one on y-axis, and this is a line. So what happened to slope or the angle with x-axis? Is it increasing, decreasing, or constant, or zero? Slope or angle with x-axis. So it is decreasing. So slope or angle is decreasing, and what about the value of the slope? When you work out the value, like the first point, that is y1, and the second point is y2. So y2 is above y1, so the value of a slope will decrease, but again it will be a positive value. Slope is decreasing. Slope means angle. As you can see, the angle with x-axis at this point is higher as compared to the second point. So if the angle is decreasing, it means the slope is decreasing. If angle with x-axis, when you measure this angle with another point, angle at another point, so you can see the angle is continue to increasing. So we have quantities on x and y axis, and this is how the graph appears. What happened to slope? Slope means angle with x-axis. Like if I draw the x-axis as first point and I draw the x-axis with the second point at a second point. So what happened to the angle? Is it increasing, decreasing? So the angle appeared to increase. If the angle appeared to increase, it means the slope is increasing. What about the value of the slope? Whether it is positive or negative? So when I take the first point, that is y1, and the second point will be y2, and you can see y1 is above y2, so it will be a negative value. So here the slope will increase, but it will have a negative value. And as another graph, So what is happening to the slope? Slope means angle with x-axis. So when we draw the horizontal line, the angle with the x-axis, so in the beginning it is much steeper, but as we move on, the angle is decreasing. So if the angle is decreasing, it means the slope will decrease. And what about the value? The value of the slope, when we check the first point, because that's a y1 and the second one will be y2. So y1 is above y2, so it will be again negative. So it will be negative slope and it is decreasing. Is it clear the concept of the positive and negative slope as well as the trend like increasing, decreasing, constant or zero? So the next part is actually related to identifying the slope and then completing the graph. Example, if you have a displacement time graph, if it is a straight line, it means the slope also we use the term gradient. So it is a constant gradient, and I mentioned for displacement time graph, the gradient or the slope represent velocity. So here as a gradient is constant, so velocity is constant. And what about the value of the velocity? It will be positive. Here it is also a constant velocity, but when we compare A with B, B is much steeper. So it means B is higher constant velocity as compared to that of A. And whereas in C, the angle is increasing, the gradient is increasing or slope is increasing. So we can say that the velocity increase. So it is accelerating because whenever there is a change in velocity, we call acceleration or basically increase in velocity. But if we have a velocity time graph, as you can see, it's a constant gradient. If it's a constant gradient, it means the acceleration is constant. As we know, the slope or the gradient, you can use the term slope or gradient and that represent acceleration. So this object is having a constant acceleration. B is also a constant acceleration, but B is higher constant acceleration than A. What about C? Because the slope is zero, gradient is zero, so it means the acceleration is zero. And when object is not accelerating, either it will be at rest or it move with a constant speed. Why here it is moving with a constant speed? Because the speed having some value. If speed was not having any value, like it was a horizontal line on the origin, it means the object is at rest. And the last one, the angle is increasing, so slope is increasing, it means the acceleration is increasing. Is it clear? The two graphs, one is for distance time and another one is for velocity time. So if we summarize this part, distance, the total length that an object moves, that we call distance. Displacement, the shortest distance between the 2 points is called displacement. Speed is a rate of change of distance, velocity is a rate of change of displacement, and acceleration is a rate of change in velocity. So for a distance time and velocity time graph, if an object is stationary, stationary means object is at rest. So distance time graph, it will be a horizontal line. Velocity time graph, it will be a horizontal line on the origin. If object is moving with a constant velocity, so because the displacement time graph, the slope represent velocity, so the gradient should be constant. Where for a velocity time graph, it will be a horizontal line above the origin, shows that the velocity is not changing. If object is having a constant acceleration, then for a displacement time graph, the slope increase, so which shows the velocity increases. But for velocity time graph, it will be a constant gradient, shows that the acceleration is constant. Then how to calculate a distance? So this distance can be shown on the graph, like we'll read the number on the y-axis and we can find what is the distance. But for velocity time graph, we have to calculate area under the graph. So it might make a triangle or it might make a rectangle or trapezium. And if we need a velocity, we can find the gradient to get velocity for this from distance time or displacement time graph. And we can use a gradient to find acceleration from velocity time graph. Then know the physical quantity derived from the slopes and area that we already discussed from displacement time, velocity time, and acceleration time graph. Include the cases for non-uniform acceleration and understand how to use these quantities. So that's our objective. So first is a display, like sometime in exam, they might give you a displacement time graph and they ask complete a velocity time graph. So how we'll complete a velocity time graph? As I explain the concept of the slope. So first what I do, like example, if in exam there was a displacement time graph is given to us and we want to plot a velocity time graph. So example, we'll divide this graph into parts, point A to B. Okay, first from point A to B, what happened to slope? That's the first thing. What is happening to slope? Is it increasing, decreasing, constant, or zero? What happened to slope? Slope means angle with x-axis. When I draw the horizontal line, the x-axis, the angle with the x-axis is known as the slope. So the slope is increasing here. You can see this angle is smaller, but the other angle is larger. So from A to B, what happened to slope? It is increasing. Is it clear, the first part? That's why the slope is increasing? Because the angle with x-axis is increasing and angle with x-axis refers to slope. Then what is the value of the slope, whether it is positive or negative, how you work out? If I take 2 points, one is on the first one on y-axis y1 and the second point y2. So you can see y1 is above y2. So if y1 is above y2, so it should be negative. So the slope should increase and it should be negative. So we have a displacement time graph and we know for a displacement time graph or dt graphs, the slope represent velocity. So what should happen to velocity? The velocity should increase, but it should be in a negative axis. So when I complete the first part from A to B only, so this is positive velocity, negative velocity, and time is there. So now what happened? The velocity should increase, but it should be negative axis or negative value. So how we represent a velocity increasing and a negative value? So we draw a line. That velocity is increasing the value, but in a negative axis. Is it clear? This part from A to B. That the velocity is increasing, the value of the velocity is increasing, and it is in a negative axis. Then B to C is a very short time interval. So what we do, we'll move from C to D. Now how to complete from C to D? Why I did not take this whole, like why I took this one is A, B, B to C is a very short time interval, can be neglected, and then C to D, and then E is there. Now what happened from C to D? What happened to slope? Is it increasing or decreasing? From C to D, what happened to slope? It is decreasing, that's right. That's correct. And what about the value of the slope? Is it positive or negative? Like when I take y1 and y2, so it is a positive value. So what happened from C to D? The velocity should decrease in a positive axis. Like the value of the velocity should decrease in a positive axis. So how we represent the value of the velocity is decreasing in a positive axis. So this is how the, as you can see, the value of the velocity is decreasing in a positive axis. So we have the point A, we have the point B, we have the point C, and we have point D. So what I can do, I can join B with C. That's a very short time interval. So I will get from B to C. Is it clear? From first from AB, and then we draw from CD, and then we join B to C. Then from D to E, what happened from D to E? From D to E, what happened to the slope? Slope is increasing. And what about the value? Yeah, that's right. Slope is increasing and it is a negative value. So means from D to E, what should happen? The slope should velocity should increase, but in a negative axis. So from D to E, the velocity increasing in a negative axis. And then continuation is there the same way we continue. Is it clear how we complete a displacement time graph and velocity time graph for a bouncing ball? Then sometime they give you the display velocity time graph and you have to complete a displacement time graph from velocity time graph. So again, we divide the graph into parts and we want to complete from, like here opposite velocity time graph is given and we want to complete a displacement time graph. Now when you check the value of the velocity, because it's already the values are there as a displacement time graph, this will not be there. You have to complete. Now when you divide this part, this is A, B and C. What is happening from A to B? What is happening to velocity from A to B? Well, to see the velocity, you just have to check the numbers on y-axis. So what happened to velocity from A to B? The velocity is decreasing because here higher velocity. So first what happened from A to B? If the velocity is decreasing, it means the slope should decrease. And what about the value of the slope? It is positive or negative? Or value of the velocity. So from A to B, the velocity is decreasing, but value of the velocity is positive. So slope should decrease and it should have a positive velocity, positive value. So how we represent a decreasing slope with a positive value? So this is a slope decreasing and it is having a positive value from A to B. Is it clear from A to B? Then from B to C, so when we want to plot opposite like reverse graph, then we have to check the y-axis. Like from if velocity time from velocity time, if we need displacement time, we only check y-axis. But if displacement time, we need a velocity time, so we check the slope. Now what happened from B to C? What happened to value of the velocity from B to C? Value of the velocity or slope? Is it increase the value of the velocity? Like here it is +1, +2, +3, -1, -2, -3. So what is happening to the value of the velocity? The value of the velocity is increasing. As the value of the velocity is increasing, it means the slope should increase. But that value is negative. So we have to plot a graph. We have to complete from B to C for which the slope is increasing and negative. So slope increasing and negative. You can see from B to C, the slope is increasing as the angle here is smaller as compared to angle here. And the value of the slope is negative. So this is a displacement time graph for this object. Is it clear how we interpret or plot displacement time graph from velocity time graph? So in short, what you will do, like example, if displacement time graph is given and you want to plot a sketch or a plot velocity time graph, then what you will do, you will check the slope and its values. But if displacement time or if velocity time graph is given and you want to sketch or plot velocity time graph, sorry, displacement time graph, then what you will do, you will check the y-axis and its value like whether it is positive or negative. Is it clear, the idea? Okay, the three graphs are given. One is about the distance, another one is displacement. Because distance is a scalar quantity and negative distance does not make any sense. Displacement is a vector quantity, so it can be a positive or negative. As like example for a bouncing ball. When a ball is bouncing or you drop an object from certain height, so when it come down, as it is coming down, what happened to displacement? Like the ball you release from certain height, so it is at certain height. So as the ball is dropped, the distance from the origin is decreasing. That's why the displacement is decreasing. At this point, the ball hits the ground. But what happened to distance? Distance is the total length covered by the object. So when we are calculating a distance, we are calculating a distance from the origin, the starting point. So from a starting point, if I say it is dropped from a height of 2 meter, so as the ball is dropped, the speed of the ball is increasing. So the distance time graph, the slope will increase. So distance time graph is like this and the displacement time graph is opposite. Why? Because we consider ground as the origin in a displacement time graph. This is a ground or a floor. So displacement is decreasing but the distance is increasing. And when you sketch a velocity time graph, you will only check the displacement time. So what happened from A to B? When you check from A to B, the slope is increasing. So if slope is increasing, the velocity should increase and it should be a negative value. So you can see from A to B the velocity is increasing and it is having a negative value. Is it clear, the first part, the distance, displacement and velocity time, the first part? Then as the ball bounce back, it is coming up, but when the ball is bouncing back, it is moving against the gravity, so it decelerate, like slow down. So how we represent displacement time graph, how we show a deceleration? slope in decreases, so speed is also decreasing. That is a deceleration. So this part it was going down, moving down, and this part it is moving up. And what about the displacement time graph? As it is rising, it is moving against the gravity above the origin, like the ground. So the displacement is increasing. And what happened to velocity? The velocity is decreasing. Why? Because when the object moves against the gravity, the velocity decreases. So when it is coming down, rebound, when it is going up, rebound, the velocity decreases. This is a displacement. Displacement is increasing, but the velocity is decreasing. And how you can identify? You can identify the slope is decreasing and it is a positive value. So slope is decreasing and it is a positive value. So when we join these 2 points, we'll get in between what happened. Is it clear? The distance time, displacement time, and velocity time graph for a falling object which bounce back. Then the weekly homework, some questions are there, doubts related to that weekly homework. Question 22, 23, and 24. And next time, try to submit this weekly homework on time so that I can discuss the doubts. 23, 20, 22, 23, and 25. So 22, the question is rearrange this equation, show that the gradient is -1 and the intercept on the y-axis is 1 over f. So how we can rearrange this equation? We have the equation 1 over f is equals to 1 over u plus 1 over v. So we have y is equals to mx plus c. And I want to show that the y-intercept is 1 over f. So 1 over f should be added with mx. So if I rearrange this equation, I can write 1 over f, 1 over u will move other side, minus 1 over u is equals to 1 over v. Or I can write 1 over v is equals to minus 1 over u plus 1 over f. So when I compare with the equation of straight line, which is y is equals to mx plus c, if on y-axis if I have 1 over v, so on y-axis if I plot 1 over v, on x-axis if I plot 1 over u, so what I'm left with my gradient will be -1, and what is the y-intercept? The y-intercept will be equal to 1 over f. So we just have to rearrange the equation and show that on the side of a gradient we have -1 and on the side of y-intercept we have 1 over f. Is it clear? Discussion? Then on to question 23, student has been given this equation. Explain why a graph of v and f will be a straight line. So we want to plot a graph between v and f. So whenever we are comparing with y is equals to mx plus c, the quantity which is on the y-axis should be separate. So if v is on y-axis, so we have this ev is equals to hf minus phi, or if e is divided, so it will be hf divided by e minus phi divided by e. So when I compare with the equation of straight line, y is equals to mx plus c. So on y-axis, if I have 1 over v, oh sorry, v, not 1 over v. On x-axis, I have f. So what will be my gradient? M is the gradient, so it will be h divided by e. H is a Planck's constant and E is also a constant. That's the charge of electron. So whenever two constants are divided, your gradient will be constant. So you will mention that the gradient is constant. And what about the y-intercept? And show how the gradient can be used to find the Planck's constant. So how we can use the gradient to find the Planck constant, where h is known as the Planck's constant. So this h is known as a Planck's constant. If we need h, So gradient multiplied by E, we will get the Planck's constant. So the first part was show that it is a straight line. How we show it's a straight line? The gradient is constant, that's why it is a straight line. And how we find the Planck constant? That the gradient multiplied by the charge will get the Planck's constant. This is related to Einstein equation that you will study in unit 2, the last of unit 2. And in 25, in an experiment to measure the viscosity of a glycerol, a steel sphere is timed falling through a column of a glycerol. Explain why a graph of V and R square should be a straight line with a gradient. So why it should be a straight line? Because you have this equation V is equals to 2 R square G, the difference in the density, divided by 9 eta. So when I compare with the equation of straight line, y is equals to mx plus c. So there is no, on y-axis if I have v, on x-axis if I have r square, and here the gradient is the y-intercept is 0. So what will be the gradient? What we are left with, that will be gradient. So gradient will be 2 is constant, g is constant, difference of the densities are constant, divided by 9, and viscosity is also constant. So we have all the constant. That's why whenever all the constants are involved in the gradient, it means it will be a constant gradient. So it is a straight line. So it will be a straight line which is passing through the origin. Why passing through the origin? Because the y-intercept is, the value of the c is 0. Is it clear? Question 25. How do I know that the value is constant? Look, 2, 2 is a number that is constant. G is a gravity. Gravity is a constant. The densities of the objects are also constant. 9 is also a number that is constant, and viscosity. So these equations, you will learn about these equations, and when you learn about the equation, you can identify what are the constant factors. So this was the doubt related to assignment SI unit. Any question related to the class today? Any doubt or a question? So I'll end the session and share this recording with you along with the weekly homework.